All right, what up, everybody? This is Mr. Stan coming at you with another physics video. And this time we are talking about concave mirrors. So, a concave mirror is where the mirror is going to be more skinny in the middle and more fat at the top. Right? So, it curves kind of inward as you're looking at it. And so, we're going to see what happens, how to do the ray tracing, and what the image would look like if someone is standing in front of a concave mirror. So to do that, we have Sir Cockroach with us, and he's going to stand inside of the focal length. So this little F right here is the focal length, and he's standing just inside of it. And there are three different rays that we can use to find the image, right? And these rays do the same thing every time with a concave mirror. Ray number one starts out parallel to the ground. Okay, so this is going to leave his head and go parallel to the ground. And then it's going to go through the focal point, right? So it's going to bounce off the mirror and go through the focal point just like that. And then we would include the virtual part on the other side of the mirror. And remember, the virtual part is just like a continuation of the reflected ray. Second ray is one that goes to the center of the mirror. And at the center of the mirror, the slope of the mirror is completely vertical, which means the light ray is just going to bounce off at the same angle it came in. So that's easier to draw than most rays. And then we'll continue the reflected ray out to its virtual part. Ray number three will start at the focal point. It'll go through the top of the object, and then when it hits the mirror, it's going to bounce back parallel to the ground, or parallel to whatever this axis is. And then you continue the virtual part right there. So just review real fast. Okay, the first one starts parallel but goes to the focal point. Second one goes to the center, bounces off of the same angle. And then the third one starts at the focal point. When it bounces off, then it's parallel. Okay? So to find where his image will be, we'll use two of those three and find out where they cross. And if we use three of them, then they should cross at the same place, but you only need two. Okay, so first we'll use ray one. It starts parallel, and remember when it reflects off the mirror, it's going to go through the focal point, just like that. And there's the virtual part. Secondly, we're going to use ray 3. Okay, we could have used ray 2, but it so happens that I happen to know this is easier, but if you used ray 2, you would have gotten the right answer. Ray 3 will start from the focal point, go through his head, and then it'll bounce off in a parallel way. And then when we draw the virtual part, which is just a continuation of the reflected ray, we'll see it crosses right here with the first ray's virtual part. So two of the virtual rays are crossing right there, so that is where the top of the image is going to be. All right. And so his image is going to be upright. It's going to be larger than he is, and it's going to be virtual. Okay, virtual because, again, there are no real light rays that are going from this image back to his eyes. Right? These light rays are virtual light rays. So his brain would see his image there. Now what happens if we move him back? So now he's going to step behind the focal length. And we're going to do the same thing. We're going to draw two of the rays and find out where they meet. We're going to draw the ray 1, which is parallel at first. And then it's going to bounce off and go through the focal point. And then we're going to do ray 2 this time, because ray 3, if you think about it, it's going to go through the focal point to his head. It's not going to be as helpful. All right. And so ray 2 is going to bounce off the center, bounce off in the same direction. And these two rays are going to meet right here. And that is where the top of his head is going to be. Okay, so this time, notice that the light rays that go from the image back to back to his actual eyes are actually real, right? There's no I know that there's virtual we drew virtual rays on this side, but none of those are in his line of sight. So this is actually a real image. Okay, it's going to be upside down, it's going to be larger than he is, and it's going to be real. Next, we're going to take him out even farther, and he's going to stand right on the 2f. So that would be twice the focal length. We'll use the first two rays again. First one is parallel at first, then goes to the focal point. Second one goes to the center and bounces off, and you'll see that they cross right there. And if we do this just right, he's actually the same size. He's just upside down. Okay, so this happens right at 2f, 2 times the focal length. So what we got so far is that when he's close up, he sees a large virtual image of himself, but when he goes back behind the focal length, he now sees a real image of himself and he's upside down. It's larger, but if he goes back to the 2f, then it's the same size. What would happen if he was standing behind the 2f? You'll have to see when you do your ray tracing assignment. All right, so that's all for concave mirrors.